Okay, I'm going to make a video showing how to solve systems of equations by graphing. Okay, so when you graph two lines, there are a few possibilities, and these are the three possibilities. So when you graph two lines, it's very possible that they could intersect, and when they do, they intersect in one point. So you'll have exactly one solution. It's also possible that when you graph the lines, you may not realize it, but they are the exact same line. They might be in just different forms. And so if that happens, they share an infinite number of points. All the points that are on the line are solutions. So all the ordered pairs. So there are infinitely many solutions, too many to count. The third thing that can happen is when you graph two lines, if they have the same exact slope, but they have a different y-intercept, they would be parallel lines, and they would never cross, and so then we would have no solution to the system. Okay, those are the three possibilities. Alright, let's look at an example. So we'll just write the system for this. So we're looking for two numbers whose sum is 12. So one equation would be x plus y equals 12. And then if we want their difference to be 2, then we will say x minus y equals 2. Now when we go to graph these, they're both really good to graph with x and y intercepts. So you can tell if you plug in a 0 for the y here, that your x-intercept would be 12. So we would put a dot right there at 12. And then your y-intercept is if you put in a 0 for the x, so then the y-intercept would also be 12. And then we would just connect the dots with a straight edge. And then the other equation is also very good to do with x and y intercepts. So we would put in a 0 for the y and solve for x. So x would equal 2. And then if we were looking for the y-intercept, we would plug in a 0 for the x. And this time you have to be careful with the negative sign. So that would mean that y-intercept would be negative 2. And then you'd graph them, and you would see where they cross. Now if you do it real carefully, you can tell that they cross at 7, 5. And then you really should verify that to see if it makes sense. So 7 plus 5 equals 12, so that works. And then 7 minus 5 equals 2, so check. Those are the two numbers we're looking for. Okay, another one, kind of a real-world one here, is the gym membership. So I'll do this one a little bit. So Gym Muscles, it says it's $40 for the sign-up fee. So that would be y equals, and it's $40 for the sign-up fee, and then it's $20 every single month. So we'd want to do 20x plus 40. And then the other one, Gym Slim, doesn't have a sign-up fee, but they charge $30 a month. So that would be $30 a month, and then plus no sign-up fee, so it would be plus 0, or we just wouldn't write it. And then we'd want to graph these. So on the x-axis, this would be the number of months, and on the y-axis, that would be the cost. So we would want to do 1 month, 2 months, 3 months, 4 months, etc. And then on the y-axis, we'd want to go probably by tens. So pretty small scale here, so I'm not sure how this will work on this graph paper, but I will try. Okay, let's see how that looks. So let's start plotting some points. So the first one, the y-intercept is 40. So I'm going to go to 40, put a nice dot, and then it says that the slope is 20, so I'm going to go up 20 and over 1, that's the rise over the run. Up 20 again, over 1, up 20 again, over 1, up 20 again, over 1. I'm going to go ahead and connect the dots. And then I'm going to go ahead and do the other equation. So this one has a y-intercept of 0, so I put a dot at 0. And this time I would go up 30 and over 1. Up 30 over 1. Up 30 over 1 to 90. And then up 30 and over 1. And it looks like this one crosses at, let's see here. So it looks like it crosses here at 4,120. So that would mean that at 4 months, they would cost the same, and the cost would be $120 for the membership. Okay, let's do a generic one here that doesn't have words. So the y-intercept is 4, so we go up to 4, and the slope is 1, so we would say that's a 1, so we write it as a fraction, so it'd be 1 over 1. So 1 over 1, 1 over 1, and then we do the same thing in the negative direction. We could go down 1 and over 1. 2 negatives would be the same thing as 2 positives. Remember, this is rise over run. And then we connect those dots. And then the other equation has a y-intercept of 5. And then the slope is up 2 and over 1. Up 2 and over 1. And remember, that's the same thing as negative 2 over negative 1. So we would go down 2 and over 1. And you can already see where they cross. So we connect those dots, and then wherever they cross, that's the solution to the system. So they cross at, looks like, negative 1, 3. So right there, at negative 1, 3. And we should always check it to make sure when we plug it in. We plug in a negative 1 right there for the x. Negative 1 plus 4 is 3, so that works. And then 2 times negative 1 is negative 2. Negative 2 plus 5 is 3, so that works as well. Let's look at just one more. Okay, so this one here is probably best to do with x and y intercepts. So you'll notice the x-intercept, if you put a 0 in for that, the x-intercept would be 7. And then for this one, if you cover up the x, then the y-intercept is also 7. So we connect those dots with a straight edge. I didn't, but works okay. So x-intercept, we cover up the y, or put a 0 in for the y, so x equals 1. Right there. And then the y-intercept, you don't want to forget about that negative sign, so the y-intercept is negative 1. Connect the dots, and it looks like they cross at 4, 3. And that's something we'd want to check. We want to verify that. So let's see, 4 plus 3 would be 7, and then 4 minus 3 would be 1, so check, that would work. So I think that's a good little review of solving by graphing. So let me just see if there's anything else here that I need to talk about. We talked about this application. So, and then the only other thing that can happen, of course, is if the two lines happen to have, let's say, situation like this, where you have y equals 2x plus 4, and you have y equals 2x minus 2, you'll notice that these two both have the same slope, and so if you were to graph it, it would have they would be parallel lines and they would have no solution. So I'll do a quick little sketch on this graph. So I'd go up to 4, I'd put a dot, and then the slope would be up 2 and over 1, so it'd look like this. And then the other one, the y-intercept is -2, so I would go down, and the slope is the same, it's 2, so I would go up 2 and over 1, and what you'd notice is that these would be parallel lines, and there would be no solution. Okay? And then the other thing is that we didn't come across yet is what would happen if they were the same line. What would that look like? So let me just find a blank space here somewhere so I could blow it up. Okay, so let's say we have the same line but we don't even realize it. So it would look like this maybe if you had y equals, actually let me back it up here. It would happen like this if you have 2x plus 4y equals 8, and then, say I divided it by 2, then it would be, like you may not even notice that those are the same exact equations, same line, but if you went to graph them both, the first one would have an x-intercept, you would put a 0 in for this, and then you divide both sides by 2, so it'd be 4. 1, 2, 3, so 4 would be your x-intercept. And then the other one, if you put a 0 in for this, then it'd be 4y equals 8, and you can divide by 4, so that'd be 2. So then you'd have that line. And then when you go to do the other line, you'd say, oh, I want to find the x-intercept, so you put in a 0 for that, y, and the x-intercept would also be 4, and then your y-intercept would be as if you put in a 0 for the x, and then you solve for y, so divide by 2, your y-intercept would also be there, and you'd see that, they're actually the same exact line. One of the equations is just multiplied by 2. If you take this equation and you multiply it by 2, you'd have that equation. That's why they turn out to be the exact same thing. So the solution to this is infinitely many solutions. Infinitely many. And it's actually any ordered pair that falls on the line itself. So it's not the same as all real solutions. It's only the ordered pairs that are actually on the line itself. So you could list several of them, but there aren't, it's not any number works, it's only the ones that are on the line. For example, 4, 0 would be a solution, 0, 2 would be a solution. Any other points that are actually on the line are sample solutions here. Alright, enjoy the rest of your weekend. That should do it.